All right, good day grade 10s. This is a video explaining some of the work that was done in the electrostatics chapter. You've already expected to have gone through the work yourself, but this is just a video to give you a bit more in-depth explanation, and if you struggle to understand a few things, hopefully this will clear it up. All right, so electrostatics, today we're dealing with charges that are stationary, coming from electro charges and statics, meaning stationary. For example, if you have a balloon and you rub your hair will gain a charge and it will have electrostatic energy repelling the hairs from one another. So when dealing with electrostatics, we have positive and negative charges, and as you know from chemistry, negative charges are associated with electrons and positive charges are associated with protons. And this example that we have on the screen, we have an atom just quickly drawn up with a positive 4 core, and as you can see here, it has 3 electrons. So it has 3 electrons and 4 protons, meaning that the net charge is positive. So if something is positive, it has more protons than electrons, and on the right hand side, we can see that it's negative. Since there's 4 protons in the core and there's 5 electrons in the outer orbitals, so 5 electrons, 4 protons, there's an excess of electrons, which means that it is negatively charged. Alright, but you already know that you've been doing electrostatics for a while. This is just to quickly remind you. So remember, when we're dealing with electrostatics, we're dealing with charge, for which the unit is coulomb, and we use the symbol Q. Use the symbol Q when dealing with charge. Alright, and remember from the beginning of the year, we dealt with all those prefixes, micro, nano, and pico. Micro being times 10 to the negative 6, nano times 10 to the negative 9, and pico times 10 to the negative 12. This is not given to you in your test. You must know what each of these mean, and you must study them as you did at the beginning of the year. So let's take a look at these examples. So positive 4 microcoulombs is 4 times 10 to the negative 6 coulombs. Alright, and then negative 6 picocoulombs, negative 6 times 10 to the negative 12 coulombs, and then if it's positive 2 nanocoulombs, then you have plus 2 times 10 to the negative 9 coulombs. Alright, remember, if it's positive, there is a shortage of electrons. If it's negative, like here, there is a excess. There's too many electrons, more electrons than protons. So let's take a look at some of the calculations that we're going to be doing in this chapter. Take a look at this object over here. It's positively charged with a charge of plus 3,2 times 10 to the negative 19. Now, this is the charge of the object in coulombs, and they're asking us how many electrons did the object lose. Since it's positive, it must have lost some electrons, either through one of the 3 ways that you can gain or lose electrons, which we'll speak about later. Okay, so we use the following formula, you can see here, to calculate the number of electrons gained or lost. It's quite self-explanatory, the formula. N is the number of electrons, you can see over here. Q is the charge on the object, and QE is the charge of an electron, which was on the screen a bit earlier. Remember, charge of an electron is 1,6 times 10 to the negative 19, which you'll see down here as well. So we're calculating N, and to calculate N, the charge of the object is 3.2 times 10 to the negative 19, 1.6 times 10 to the negative 9 for the charge of the electron. And you can see that the 2 at the end are the same, the 2 suffixes, times 10 to the negative 19. So 3.2 over 1.6 equals 2 electrons. You don't need to worry about the charge over here. We're just looking at the size of the charge of an electron. So this object, previous question, this object that has a charge of 3.2 times 10 to the negative 19 coulombs lost 2 electrons. Simple enough. Just a few scenarios that we deal with when looking at charged objects. As you know, opposites will attract each other. So, for example, if I have this positively charged object and this negatively charged object, they will attract each other, and the electrons will flow from the negative to the positive. It's important to know which direction the electrons will flow, since they can ask you that in any of your questions. So remember, the flow of electrons is always from negative to positive until they both have the same charge, which we'll take a look at in the following calculations. But first, if you have two positive objects like these ones here, they will repel each other. But if they are brought into contact with one another, you will see that the charge flows from the least positive to the most positive. It's important to know that because they can ask you which direction did the electrons flow, from object A to B or B to A. So you need to be able to interpret the scenario given to you. And then when dealing with negative, the charge, two negative objects, the charge will flow from the most negative object, meaning the one with the greatest negative charge. Okay, so let's take a look at the example here. I have an object with a charge of +2 coulomb and an object with a charge of -4 coulomb. So they have opposite charges, meaning they will be attracted to one another. I bring these two objects into contact with each other and electrons will flow. As I said previously, we know the electrons here will flow from the negative to the positive. But just to give you an idea of what the net charge or the charge at the end will be, I'm quickly going to explain it in the following steps. So for example, let's say 1 coulomb of charge goes over, 1 coulomb of charge goes over from the -4 coulomb to the +2 coulomb. Then this one, then the left hand has a charge of 1 and the right hand has a charge of -3. Okay. Then you take another coulomb over and this one has a charge of 0. Because 1 minus 1 is 0, and you've taken a -1 away, and this one becomes -2. I take another coulomb over, and then both of them have a charge of -1 coulomb. When both objects have the same identical charge, their flow of electrons will cease, since they both have identical charges. There's no place for the electrons to flow to. Okay. So when both of them have identical charges, they will repel each other if they are charged, and we can calculate this netto charge at the end with the following formula that you can see here, which you've used many times before. Okay, but as you can see from the previous one, +2 -4, if I put that into the formula here, I can say +2 -4 all over 2. The answer is going to be -2 over 2, which is -1 coulomb, which is what we see here in our example. So let's take a look at another example here. Two objects with a charge of -4 picocoulomb and -5 nanocoulomb are brought into contact. Now, what is the new charge? Immediately we know we need to write the formula. It's important to write the formula as you get marks for it in your tests. And this is the same rules that apply all the way through to matric. So it's important to remember these little things. So -4 picocoulomb, meaning -4 times 10 to the -12, and we add -5 nanocoulomb, -5 times 10 to the -9 coulomb. We put all of that over 2 since there are two objects, and if you pop that into your calculator, which you must be good at by now, you will find that the answer is -2.502 times 10 to the -9 coulomb. Alright, you don't have to worry about rounding now, but usually they'll instruct you to round off to about 2 decimal places. Okay. Another example, we have two objects, object A and B. Object A has a charge of -5 nanocoulomb and object B has a charge of -1 nanocoulomb. Both are brought into contact and they ask us what is the new charge. Simple enough, we just substitute in -5, -5, -1, -1. Alright, what's important to note here is you'll see that both of them are nano. See nano and nano, and you keep your final answer in nano then as well. If both have the same suffix. Both of them are nanocoulomb or both of them are microcoulomb. Then you can only add, you only have to add it at the end. You don't have to go and write down minus 5 times 10 to the negative 9 directly into the equation like that. But that's only if they both have the same unit. Alright, now the next calculation and type of question they can ask you is the number of electrons transferred between objects. So, for example, in the previous one, we had object A and B. Now, think for yourself, from which one to which one will the electrons have flowed? From A to B or B to A? Think about that for a second. Hopefully you remembered that it will be A to B, since A is more negative. Negative 5 nanocoulomb is much more negative than minus 1 nanocoulomb. Alright, so they ask us how many electrons flowed from A to B in the previous example. And we use this formula to calculate that. Remember, Q is the unit for charge. Delta, over here, delta means change. The F is final, and the I is initial. So F is the final charge. What do we calculate the final charge to be? Over here we can see it's minus 3 nanocoulomb. So we substitute that in, minus 3 nanocoulomb for the final. Remember, keep the negative sign there. And what's the initial charge on object A? It was minus 5 nanocoulomb. So then we say minus 5 nanocoulomb. So you substitute that in, and the answer is positive 2 nanocoulomb, which is the change in charge, delta meaning change. But the question asked us the number of electrons. If you think a bit back, we spoke about this formula over here for the number of electrons. Number of electrons equals charge over charge of electron. So the change in charge, which you calculated previously, delta Q, as you can see here, delta Q, we calculated to be 2 nanocoulomb. So we substitute that in, 2 times 10 to the negative 9, all the way over 1.6 times 10 to the negative 9. Substitute that into your calculator, and you'll find 1.25 times 10 to the 10 electrons. Simple enough. Alright, so let's take a look at this example from the worksheet that some of you already completed, maybe some of you didn't, but let's take a look at this example. Consider two charged spheres. Sphere A has a charge of plus 2 coulomb. Now, to make it more applicable, I made this microcoulomb since the nanocoulomb would be too small to have an impact. So let's keep this one. Object A has a charge of 2 times 10 to the negative 6 coulomb, microcoulomb. And object B has a charge of positive 600 times 10 to the negative 9 coulomb as well. They're brought together to touch and then separated. Calculate the new charge on each sphere. Alright, so the steps. We calculate Q new is equal to Q1 plus Q2 all the way over 2. The first one is 2 times 10 to the negative 6 plus 600 times 10 to the negative 9. Alright, all of that all the way over 2, and quickly get that on your calculators. The answer should be here, so it's 2 times 10 to the negative 6 plus 600 times 10 to the negative 9. All of this are 2. And our answer is 1.3 times 10 to the negative 6. Alright, so we get the answer is 1.30 times 10 to the negative 6 coulomb. Alright, and that's the charge on each sphere. Now, to take the question a bit further, I'm going to ask you how many electrons was transferred. So, if you think back to what we just did, the formula for that would be we use delta Q, which is QF minus QI, and we can go back to the previous one to just calculate that. So in this example, sphere A and sphere B, which one was more positively charged? Micro is much bigger than nano, so sphere A is the object from which the electrons will flow. Or is it the other way? Because when you have two positive objects, the charge will flow from, let me just draw here, object A and B. A is plus 6 microcoulomb, plus 2, and this one is plus 600 nanocoulomb. This charge is greater, but the electrons will flow from B to A since he is less positive. Okay, so to calculate the number of electrons transferred, let's take it like this, and then we'll see that delta Q is equal to the final charge, which we calculated is 1.30 times 10 to the negative 6 minus the initial charge, which is 600 times 10 to the negative 9. And if we calculate that, we will find the answer. So let's see who can get it first, you or me. So 1.3 times 10 to the negative 6. Let's just there. Okay. So brackets 1.3 times 10 to the negative 6 minus 600 times 10 to the negative 9. And the answer is 7 times 10 to the negative 7. Okay, so 7 times 10 to the negative 7 coulomb. And then just the last step, N equals Q over QE. So 7 times 10 to the negative 7, all the way over 1,6 times 10 to the negative 19. If we substitute that back in to the calculator, and then we'll find 7 times 10 to the negative 7, all the way over 1.6 times 10 to the negative 19. We get 4,38 times 10 to the 12 electrons. All right. Yeah, that should do for today for the calculations. Videos of the rest of the work will also follow, and good luck. So take a look at this video, complete the worksheet exercise 10 in your scripts, and let us know if you have any questions or any difficulties.